Okay, so you've done it. You've landed that big data analyst interview, maybe with a huge company like American Express. First off, congratulations. That's awesome. So what we're going to do in the next few minutes is build out your complete playbook for that technical SQL round. We'll hit the core concepts and the exact kind of real-world problems you're almost guaranteed to see. All right, picture this. You're in the interview room, right? And that first technical question lands on the table. Now here's the secret. They're not just testing if you remember the syntax. Not at all. What they really want to see is how you think. How do you break down a problem? How do you turn a messy business question into clean, efficient SQL code? That's the real test. So here's our game plan. We're going to start with the absolute fundamentals, the must-haves. Then we'll level up to the advanced techniques that are going to make you stand out from the crowd. And finally, this is the fun part, we'll apply all of it to the kind of real-world business problems you'll actually face on the job. Sound good? Let's dive in. First up, we've got to talk about the bedrock of any SQL interview, joining tables. Seriously, this is non-negotiable. It's all about how you take different pieces of data, like a customer list from one table and their orders from another, and combine them to see the whole picture. You absolutely, positively have to nail this. Let's start with the inner join. The easiest way to think about this, it's like the overlapping part of a Venn diagram. It's the intersection of your data. So if you're joining a customers table and an orders table, an inner join gives you only the customers who have actually placed an order. It's all about finding that perfect one-to-one match. Okay, but what if you want something different? That's where the left join comes in. A left join is your best friend when you want to keep every single record from your first table, the left one, no matter what. If it finds a match in the second table, great. If it doesn't, no problem. SQL just puts a null there like a little placeholder. This is so crucial when you need to see everything from one side of the equation. So here's the bottom line. The thing you have to remember, use an inner join when you only care about the perfect matches, the overlap. But use a left join when you're on a mission to find out what's missing. Think about it. How would you find customers who haven't made a purchase yet? That's a classic left join problem right there. It's the perfect tool for the job. Okay, so we can combine data. Awesome. But what's next? Well, now we have to summarize it. This is where the magic really happens. Aggregation is how you take like millions of messy rows of raw data and boil them down into a few powerful numbers that actually tell you a story. Now, this next one, this is a classic interview trip-up question, so listen close. Group by versus having. Just remember this one simple rule. Where filters the ingredients before you cook. Having filters the final dishes after you've cooked them. So, where acts on individual rows before grouping, and having acts on the groups themselves after they've been created. Simple as that. So, let's put this into practice. Imagine your manager comes to you and asks, hey, which of our departments have more than 5 employees? See, they don't want a list of 10,000 people. They want a summary. And this is a perfect job for group by and having. You have to first group all the employees by their department, count them up, and then filter out the groups that are too small. And here's what that looks like in code. It's pretty straightforward when you break it down. First, we group by department ID. That bundles everyone up into their little department groups. Then, the magic part, having count star greater than 5. That looks at each of those newly formed groups and asks, hey, are you bigger than 5? If the answer is yes, it makes the cut. This pattern, you're going to see it a lot, for sure. All right, you've totally got the fundamentals down. Let's level up. Now we're going to talk about the power tools. These are the functions and techniques that tell an interviewer, hey, I'm not just a beginner, I know the real deal. This is how you signal that senior level thinking. Have you ever needed to do something like calculate a running total, or maybe rank the top sellers within each region? But here's the catch. You need to do it without squashing all your data down into one row. That is exactly what window functions are for. Unlike group by, which collapses everything, a window function lets you perform these cool calculations across a window of rows while keeping all your original detail. Okay, so a super common interview question is something like, rank employees by salary within each department. Easy enough, right? But then comes the follow-up. How do you handle ties? Boom, that's where you show your stuff. Row number is simple. It just gives every single row a unique number, 1, 2, 3, 4, even if there's a tie. But rank? Rank is smarter for leaderboards. It gives ties the same rank, but then it skips the next number. So you might see ranks like 1, 1, 3. Knowing that distinction is absolutely critical. You know those queries that are just a total mess? Like subqueries nested inside other subqueries? They're impossible to read. Well, your secret weapon against that mess is the Common Table Expression, or CTE. A CTE using the with clause lets you create these little temporary named tables right at the beginning of your query. It's the best way to break a huge, scary problem into small, manageable, readable steps. I love this analogy. Think of a CTE as your mise en place in the kitchen. Getting all your ingredients prepped and organized before you start cooking the main dish. That's what a CTE does for your query. And when you use them in an interview, it shows you don't just write code that works. You write code that's clean, maintainable, and easy for your future teammates to understand. That's a huge win. Okay, this is it. This is where everything we've talked about comes together. The interviewer isn't just going to say, "Write me a left join." No way. They're going to give you a real business problem, a scenario, and your job is to take that scenario and translate it into a beautiful working SQL query using all the tools in your new playbook. And here's the all-time classic business problem. How do we identify customer churn? Churn is just a fancy word for customers who've stopped doing business with you. The company needs to know who these people are, and it's our job as analysts to dig into the data and find them. Now, pro tip, a great analyst never, ever jumps straight into writing code. Nope, they strategize first. Step 1 is always to define the problem. What does churn even mean here? No purchases in 6 months? A year? You have to ask. Step 2, figure out where the data lives. Which tables do you need? And only then, as step 3, do you start actually formulating the query. That structured, step-by-step thinking is exactly what interviewers are looking for. And here's how we pull off that strategy with code. Remember our old friend, the left join? We use it here. We take our main customers table and left join it to only recent transactions. Now, think about it. For an active customer, the join will find a match. But for a turned customer, someone with no recent activity, that join is going to come up empty. The transaction fields will be null. And that's our signal. We just filter for where the transaction ID is null, and boom, there's your list of turned customers. All right, here's another huge one, a real multi-million-dollar question. The business always wants to know, how are we doing this year compared to last year? This is year-over-year growth. And the challenge is that you have to compare 2 different time periods inside a single query. Now, this query can look a little scary at first, I get it, but let's walk through it. First, we use a CTE, our prep station, to create a simple temporary table with the total revenue for each year. Easy enough. Then, the main query does something really clever. It joins that little table back onto itself. We're matching each year with the year that came before it. Once you have this year's revenue and last year's revenue sitting side by side in the same row, the rest is just simple math to get the growth percentage. Okay, for our final section, let's talk about something that truly separates the pros from the amateurs. See, it's not enough for your query to just be correct. In the real world, with massive data sets, it also has to be fast and efficient. Look, you don't have to be a database admin, but just showing that you think about performance is a massive plus. You can mention things like checking for an index on the columns you're joining on. An index is basically a table of contents that makes searching way faster. Or you could say you'd avoid select star because it's lazy and you should only pull the specific columns you actually need. Dropping little hints like this shows the interviewer you're thinking about efficiency and scale, and that's a huge deal in any real data job. So there you have it. That is your playbook. We went from the basic joins all the way to advanced problem solving. Just remember, this interview isn't a test of your memory. It's a chance for you to show them how you think. It's about proving you have the skills to take a pile of raw data and turn it into something that actually matters to the business. You've got the tools, you've got the playbook, now go show them what you can do.